All right, and welcome back. In this video, we are going to be going through Chapter 7, Section 2, titled Properties of Proportions. By the end of this video, we should be able to solve for an unknown term in a given proportion, as well as express a given proportion in an equivalent form. So please have out your guided notes. Let's begin. So the first and last terms of a proportion are called the extremes. The middle terms are called the means. So if we have the proportion of A over B equal to C over D, A and D are going to be the extremes, and B and C will be the means. And the properties of proportions you will be using are given along with examples of each property. When you use one of the properties in a proof, you can give a property of proportions as your reason. So here's the properties of proportions. So the product of the means is equal to the product of the extremes. This is called the means extremes property of proportions. So if we are given if 2 over 3 is equal to 4 over 6, then 2 times 6 is equal to 3 times 4. Secondly, if you interchange the means, you get an equivalent proportion. So again, if we're given 2 over 3 is equal to 4 over 6, then 2 over 4 is equal to 3 over 6. If you take the reciprocals of the ratios, the result is an equivalent proportion. So if 2 over 3 is equal to 4 over 6, then 3 over 2 is equal to 6 over 4. If you add 1 to both sides, you still have an equivalent proportion. So if 2 over 3 is equal to 4 over 6, then if I add 3 to the numerator and I add 6 to the numerator on the second fraction, it's still going to be equivalent. And the reason why we're able to add 3 is I'm adding 3 over 3. So I have 2/3 plus 3/3. A common denominator is 3, so we do 2 plus 3. Likewise, if we have 4 over 6 plus 6 over 6, I'm really doing 4 plus 6 over the common denominator of 6. 5, in an extended proportion, the ratio of the sum of all the numerators to the sum of all the denominators is equivalent to each of the original ratios. So if I have 2 over 3 is equal to 4 over 6, which is equal to 6 over 9, then the sum of my numerators, 2 plus 4 plus 6, is 2, 4, and 6. And that's still equivalent to 3 plus 6 plus 9. That's still going to have an equivalent ratio at the very, very end. And in example number 1, we are asked to complete the following two statements. If x to 4 is equal to 3 to 7, then 7x is going to be equal to what? And if 3 over x is equal to 5 over y, then x over y is going to be equal to what? The solution, using the means extremes property, we have 7x is equal to 12. And by interchanging the means, we can say x over y is equal to 3 over 5. With this in mind, please work on problems 1 through 6 on the guided notes and resume when you're ready to move forward. So to decide if two proportions are equivalent, it's usually easiest to apply the means extremes property to both and compare the results. So in example number 2, we are asked which equations are equivalent to 3 over 4 equaling x over y. Is it A, 3x equals 4y? Is it B, 7 over 4 is equal to x plus y over y? Well, if 3 over 4 is equal to x over y, then 3y is equal to 4x. So A, 3x equals 4y, that's not the same as 3y equaling 4x. So the equations are not equivalent. For B, if 7 over 4 is equal to x plus y over y, then 7y is equal to 4 times the quantity x plus y. Well, we end up with 3y is equal to 4x. As we distribute the 4, we get 4x plus 4y. Take away 4y on both sides, and we end up with 3y equaling 4x. So those equations are indeed equivalent. With this in mind, please work on problem number 7 on the guided notes and resume when you're ready to move forward. In example number 3, we are asked to find the value of x for these three proportions. For A, we have 3 over x is equal to 2 over 5. For B, we have 3 over 5 is equal to 7 over x minus 1. And C, we have x minus 1 over x plus 3 is equal to 3 over 5. For A, we're going to use the means extremes here. We're going to multiply 3 and 5 to get 15, and 2 and x to get 2x. Divide both sides by 2. We end up with x is equal to 7.5. We are again going to use the means extremes. We're going to do 3 times the quantity of x minus 1 and 7 times 5. We end up with 3x is equal to 38, and x is equal to 38 over 3. And if you write it as a mixed number, it's going to be 12 and 2/3. For C, we're going to use that means extremes. We're going to multiply the quantity x minus 1 by 5 and the quantity of x plus 3 by 3. Once we simplify, we end up with 2x equaling 14 and x being equal to 7. With this in mind, please work on problems 8 through 17 on the guided notes and resume when you're ready for one last example. In example number 4, we're given in the figure AD over DC is equal to AB over BC. If AC is equal to 18, AB is equal to 12, and BC is equal to 15, we need to find the lengths of AD and DC. So when it comes to our solution, we're going to let AD be x because we don't know it. Then we know that the length of DC is equal to 18 take away x. Since 12 over 15 is equal to 4 over 5, x divided by 18 minus x is also equal to 4 over 5. From here, we can multiply. We get 5x is equal to 72 minus 4x. And we end up with x is equal to 8. And AD is 8. DC is now 18 take away 8, which is 10. Awesome job with this. Please work on problems 18 through 20 on the guided notes. Great job today. Keep making yourself proud. Let us know if you have any questions, and we'll talk to you soon.